The biggest communication network on this planet is not the internet. It's not satellites. It's not 5G. It's something you've been stepping on your entire life. Right now, underneath the nearest forest, there is a living network that is older than trees, older than dinosaurs, older than almost everything you've ever heard of. It has no brain, it has no eyes, and yet it solves problems that stump engineers. It feeds entire forests, and it may actually remember things. 1 teaspoon of healthy soil can contain 8 miles of these threads, all connected, all working. Right now, this is mycelium. By the end of this video, you will never look at the ground the same way again. If you're into the hidden science of nature, subscribe. We go deep on this stuff every week. So what are we actually looking at? When you see a mushroom poking out of the ground, that's just the tip. It's like an apple on a tree. The real organism, the actual body of the fungus, lives underground. It's called mycelium, and it's made of microscopic threads called hyphae. Each thread is thinner than a human hair, but together, a single network can cover miles. And I mean that literally. The largest living thing on Earth is not a whale, not a redwood tree. It is a fungus in Oregon. One single connected organism spreading across almost 2,400 acres. It has been alive for somewhere between 2,000 and 8,000 years. That's not a colony. That's one individual, still growing, still feeding, still communicating underground while we walk around above it having no idea. And the way these networks are shaped, they look almost identical to the structure of the internet. Same math, same pattern. Nature figured it out 450 million years before we plugged in our first cable. Now here's where it gets wild. In the year 2000, scientists in Japan took a slime mold, a close cousin of fungi, and put it at the entrance of a maze. Food was at the exit. There were no instructions, no hints. The organism sent threads into every single corridor at once. When a path hit a dead end, it pulled back. When a path found food, it grew thicker. Within 4 hours, it had mapped the shortest route through the entire maze. But wait, when they gave it 2 food sources, it did not just connect them by the shortest path. It also built a backup route, a second connection slightly longer, just in case the first one was cut off. That is exactly what network engineers try to do when they design the internet. Shortest path plus redundancy. And this organism did it with no brain, no plan, and no computer. The trick is simple but brilliant. Paths that work get thicker. Thicker tubes carry more flow. More flow makes them even thicker. Paths that fail get thinner and disappear. It is a physical feedback loop that solves complex problems in real time. This is the same basic principle behind artificial intelligence. Mycelium was running this algorithm hundreds of millions of years before anyone wrote a line of code. Okay, so it solves mazes. Cool. But here is where it actually matters for the planet. About 90% of all land plants are connected to fungi underground. The deal is simple. The plant gives the fungus sugar, up to 30% of everything it makes from sunlight. In return, the fungus extends the plant's reach underground by an enormous factor, pulling in water, phosphorus, nitrogen, things the roots alone could never get. But it does not stop there. These networks connect tree to tree and resources flow between them. Scientists discovered that big, healthy, mature trees, called mother trees, actually send more food through the fungal network to their own offspring than to random seedlings nearby. The network recognizes kin, without a brain. Even crazier, when a tree is struggling, say it is in the shade, not getting enough light, its neighbors increase their resource transfers to that specific tree through the shared network. Not randomly, directionally, toward the one that needs it. Nobody is deciding this. There is no manager. There is no plan. It is pure chemistry and physics, and yet the result looks like generosity, like a forest taking care of its own. Here's something most people never think about. Where did soil come from? 450 million years ago, the land was bare rock. No trees, no grass, no dirt, nothing. The very first plants that crawled out of the water could not have survived alone. They didn't have real roots yet. They couldn't get minerals from rock, but fungi could. Fungi produce a substance called oxalic acid that literally dissolves rock. It breaks minerals free, especially phosphorus, which is the backbone of DNA and the fuel that every living cell runs on. So here's the deal. Fungi cracked the rock. Plants made the sugar. Together, and only together, they built the first soil on Earth. And every ecosystem on land since then has been built on top of that partnership. The ground under your feet, fungi built it. That is not a metaphor. That is chemistry. And they're not done working. One of the most exciting areas of research right now is using fungi to clean up pollution. In one experiment, soil contaminated with diesel fuel was treated with oyster mushroom mycelium. After 4 weeks, 89% of the toxic compounds were gone. The control group, treated with standard methods, barely changed. The reason is fascinating. Fungi evolved enzymes to break down wood, one of the toughest natural materials on Earth. Those same enzymes happen to shred the molecular bonds in oil, pesticides, and industrial chemicals. Evolution built a cleanup crew for dead trees, and it turns out that same crew can handle our mess too. Some fungi even soak up heavy metals, lead, cadmium, copper, concentrating them in their mushrooms. You harvest the mushrooms, you remove the poison from the soil. It is not science fiction. The EU and the US military are both funding this research right now. But here's maybe the most mind-blowing part. When a disease attacks one part of a fungal network, the signal travels, not just to the nearest neighbor, through the entire connected web. And distant parts of the network, parts that have not even been touched yet, start producing defensive chemicals before the threat arrives. Trees plugged into healthy fungal networks get sick less often, not because the fungi kill every pathogen, but because the network acts like a shared immune system across the whole forest. The immune system of a forest does not live in any single tree. It lives in the connections between them. And by the way, many of our most important medicines came from this underground war. Penicillin is a fungal weapon against bacteria. The drug that makes organ transplants possible comes from a soil fungus. Statins for heart disease come from a fungus. Every time fungi fought to survive underground, we ended up with medicine. So let's bring it home. Right now, underneath your feet, there is a network that has been running for nearly 500 million years. It has no brain, and yet it solves engineering problems. It has no eyes, and yet it finds the most efficient paths. It has no language we can read, and yet scientists have recorded electrical signals pulsing through it in patterns that resemble words. Up to 50 distinct signal types. We discovered the internet in the 1960s. Mycelium built its version before fish had jaws. We have mapped maybe 10% of all fungal species on Earth. We have studied a fraction of those. The story of mycelium is still being written, and we are barely past the first page. Drop a comment. What hit you hardest? The maze, the fact that fungi built the soil, the underground immune system? I want to know. And if you want to go deeper, there's a video right here that covers the most studied medicinal fungi and what the science actually says about them. I'll see you there.